Look around you for a moment. Notice the colors, the shapes, the sense that you are here in a solid, stable world. It feels obvious, doesn't it? As if your eyes are windows and your brain is simply showing you what's out there. But what if that feeling, this sense of direct access to reality, is one of the brain's most convincing illusions? Your brain is locked inside a dark, silent skull. It never touches the world directly. It doesn't see light, hear sound, or feel objects. All it ever receives are tiny electrical signals. And from those signals, somehow, it constructs a rich, meaningful experience of a world filled with people, objects, emotions, and even a sense of you. So here's the surprising idea. Your brain is not showing you reality as it is. It's showing you its best guess of what's out there. When we think about perception, it feels natural to assume that our senses work like cameras and microphones, passively recording the world and delivering it to the brain. Light enters the eyes, sound enters the ears, signals travel inward, and somewhere inside our head a picture of reality appears. This idea is deeply intuitive, and it feels right because perception feels immediate and effortless. But this intuition is misleading. Perception is not something that simply happens to us. It is something the brain actively does. To understand this, it helps to start with a basic constraint: the brain is physically cut off from the world. It sits in complete darkness and silence, sealed inside the skull. There are no colors, sounds, or objects inside the brain itself. Instead, all the brain ever receives are electrical and chemical signals carried by neurons. These signals are not labeled. They don't come with tags saying, "This is a tree," or "This is your friend's voice." They are just patterns of activity. From these patterns, the brain has to work out what is most likely happening outside the body. This means perception cannot be a direct readout of reality. There is no direct access. The brain must interpret, infer, and construct. It must take incomplete, noisy data and turn it into something useful. And usefulness, not accuracy, is the key. Evolution did not shape brains to reveal objective truth. It shaped brains to keep bodies alive. Perception, then, is best understood as a biological solution to a survival problem. Rather than waiting for the world to imprint itself on the mind, the brain is constantly generating predictions about what is out there. These predictions are based on past experience, learned regularities, and the body's current needs. Sensory input does not create perception from scratch. Instead, it acts more like a stream of updates that correct or refine the brain's ongoing guesses. When the incoming signals roughly match what the brain expects, perception feels smooth and stable. When they don't, the brain adjusts its model. This flips the usual story upside down. We tend to think perception flows from the outside in, from world to senses to brain. In reality, much of perception flows from the inside out. The brain is continuously asking, what is the most likely cause of these signals right now? What you experience is the brain's answer to that question. This is why perception feels so immediate and real. You are not aware of the brain's guessing process, only of the final result. Just as you are not aware of the calculations a calculator performs, you are not aware of the predictions your brain is making. You experience the output, not the process. And because the process is hidden, the output feels like reality itself. Illusions make this clearer. When you see an optical illusion, it feels as if your eyes are deceiving you. But your eyes are doing their job just fine. The illusion reveals the assumptions your brain is making. The brain applies rules that usually work well in the natural world, such as assuming light comes from above or that objects maintain constant size. In artificial situations designed to exploit these rules, perception goes wrong. But it only goes wrong relative to objective measurement. From the brain's perspective, it is doing exactly what it is designed to do, making the most plausible interpretation, given limited information. This same constructive process applies to everything you perceive, not just vision. Sounds are inferred causes of air pressure changes. Smells are inferred causes of chemical signals in the nose. Even the sense of time passing is actively constructed, shaped by attention, emotion, and expectation. There is no single sense that gives us reality raw. What makes this especially striking is that the brain's constructions are constrained not only by sensory data but also by the body. Signals from the heart, lungs, gut and muscles constantly inform the brain about the body's internal state. Perception is therefore not just about the external world, it is also about regulating the body. What you see, hear, and feel is influenced by what your body needs. Hunger can change how appealing food looks. Fear can sharpen certain perceptions while dulling others. The brain's goal is to keep the body within a viable range, and perception is one of its tools. This helps explain why two people can experience the same situation very differently. Their brains bring different histories, expectations, and bodily states to the moment. Perception is not a shared photograph, but a personalized construction. The world we experience is shaped by who we are and what we have learned. Importantly, saying that perception is constructed does not mean that nothing is real or that reality doesn't exist. There is a real world out there, with physical properties that place constraints on what we can perceive. If perception were completely unconstrained, it would be useless. The brain's predictions must be continually tested against incoming signals. When predictions fail badly, the brain updates them. This constant negotiation between expectation and input is what keeps perception tethered to the world. But the tether is not a mirror. It is more like a model. And models are simplifications. They leave things out. They emphasize what matters for the task at hand. Your experience of reality is therefore a user interface, not a blueprint. It highlights what is relevant for action and hides what is not. Understanding perception as an active construction has deep implications. It challenges the idea that we all see the same world in the same way. It invites humility about our experiences and openness to the perspectives of others. It also changes how we think about the mind itself. The brain is not a passive receiver, but an active generator, constantly working to make sense of uncertainty. Once you grasp this, the world does not become less meaningful. If anything, it becomes more remarkable. Every moment of experience is the result of an intricate dance between brain, body, and world, unfolding seamlessly and silently. What feels like a simple act of seeing is actually a triumph of biological imagination, a living process that turns signals into significance and guesses into experience. When we talk about the brain, we often imagine it as a truth-seeking machine, a device designed to discover how the world really is. We assume its job is to collect accurate information, eliminate errors, and present us with a faithful picture of reality. But this assumption reflects our intuitions more than it reflects biology. From the brain's perspective, truth is not the primary goal. Survival is, and prediction, not accuracy, is the strategy evolution has settled on to achieve it. To stay alive, an organism must act before it is too late. It must move away from danger toward resources and adjust its internal state to changing conditions. Waiting for perfect information would be disastrous. By the time certainty arrives, the opportunity to act may already be gone. So the brain evolved to anticipate rather than react. Its central task is to predict what is about to happen next and prepare the body accordingly. At every moment, your brain is running a vast number of predictions about the causes of its sensory inputs. It predicts what you are likely to see, hear, and feel. It predicts how your body should respond. It predicts the consequences of your actions before you perform them. These predictions are generated using prior experience, learned patterns, and assumptions about how the world usually works. Sensory input then serves mainly to correct these predictions when they go wrong. This predictive approach is efficient. Instead of building perception from the ground up each time, the brain starts with a hypothesis and checks whether the incoming signals fit. If they do, the prediction stands. If they don't, the brain updates its model. Most of the time, the mismatch between prediction and input is small, so perception feels stable and continuous. You experience a world that seems steady and obvious, even though it is constantly being inferred. From this perspective, the brain is less like a scientist seeking objective truth and more like a forecaster trying to minimize surprise. Surprise, in biological terms, is dangerous. It signals that the brain's model of the world is failing, which can threaten the body's stability. Prediction helps keep surprise within manageable limits. By anticipating what is likely to happen, the brain keeps the body prepared and in balance. This is especially clear when we consider the brain's role in regulating the body. A large portion of the brain's activity is devoted not to thinking or perceiving the outside world, but to predicting the body's internal needs. It anticipates how much energy will be required, how heart rate and breathing should change, how temperature should be regulated. These predictions help keep the body alive by staying one step ahead of demand. In this sense, perception itself is deeply tied to bodily regulation. What you experience is shaped by what your body needs to remain stable. Because the brain is focused on prediction, it often favors interpretations that are useful rather than ones that are strictly accurate. For example, it may exaggerate threats when you are anxious or highlight opportunities when you are motivated. These biases are not flaws in the system. They are features. They reflect the brain's attempt to guide action in a complex and uncertain world. This also explains why changing expectations can change experience. If you expect something to hurt, it often does hurt more. If you expect a task to be difficult, it often feels more demanding. The brain's predictions shape how sensory input is interpreted. The signals themselves do not change, but the brain's model does, and that model determines experience. Importantly, prediction does not mean the brain ignores reality. Predictions must be anchored to sensory evidence, or they become useless. When predictions consistently fail, the brain is forced to revise them. This constant adjustment keeps the brain's model aligned with the world. But alignment is not the same as truth. The model does not aim to capture every detail of reality. It aims to be good enough to guide behavior. This is why different people can hold very different interpretations of the same situation and still function effectively. Their brains have learned different predictive models based on their histories, cultures, and environments. There is no single, privileged model that reveals the world exactly as it is. There are only models that work better or worse for particular bodies in particular contexts. Understanding the brain as a prediction machine also reshapes how we think about mistakes and errors. When perception or belief turns out to be wrong, it is tempting to see this as a failure of the brain. But errors are inevitable in a system that prioritizes speed and usefulness over certainty. What matters is not avoiding error altogether, but correcting it when it becomes costly. The brain is constantly balancing this trade-off. Seen this way, the feeling of being in touch with reality is not evidence that the brain has succeeded in discovering truth. It is evidence that its predictions are currently working well enough. The world feels stable when the brain's model is reliable, not when it is perfectly accurate. Reality, as experienced, is a controlled outcome of successful prediction rather than a direct revelation of how things truly are. When we say that what we experience feels real, because it is useful rather than because it is accurate, we are challenging one of the deepest assumptions we have about our minds. We tend to believe that the vividness and certainty of our experiences come from their closeness to the truth. If something looks solid, sounds loud, or feels intense, we assume that this intensity reflects how things truly are in the world. But the brain does not work to maximize truth. It works to maximize viability. The feeling of reality is not a stamp of accuracy. It is a signal that the brain's construction is good enough to guide action. To see why usefulness matters more than accuracy, it helps to remember what kind of problem the brain evolved to solve. For most of human history, survival depended on making fast, effective decisions in uncertain environments. There was no reward for perceiving the exact wavelength of light reflected off a predator's fur. What mattered was recognizing danger quickly enough to run. A perception that was slightly distorted, but fast and reliable was far more valuable than one that was perfectly accurate, but slow or fragile. This means that the brain prioritizes interpretations that help the organism act. The world you experience is shaped around what you can do in it. Objects appear at a scale that makes grasping and avoiding possible. Colors separate things that matter from their backgrounds. Sounds are localized in ways that support orientation and movement. Your experience is tuned to relevance, not precision. This tuning is why perception often ignores enormous amounts of physical detail. The world contains far more information than the brain could ever process, so the brain filters, compresses, and simplifies, it creates a version of the world that emphasizes what matters for survival and behavior. The result feels rich and complete, but it is actually highly selective. What you do not notice vastly outweighs what you do. The feeling of reality emerges when this selective model works smoothly. When perception supports effective action, the brain treats its own construction as trustworthy. This trust is experienced subjectively as "this is real." But this feeling does not guarantee that the construction matches the world in a literal sense. It only means that the model is currently serving its purpose. Illusions make this especially clear. When you experience an illusion, it often feels just as real as ordinary perception. The lines still look bent. The colors still seem to change. Even when you know intellectually that what you are seeing is misleading, the experience itself does not vanish. This tells us something important. The feeling of reality is not controlled by knowledge of truth. It is controlled by the brain's ongoing attempt to generate a useful model. The same principle applies to emotions. Fear, joy, anger, and sadness all feel deeply real, as if they are direct readouts of the world's significance. But emotions are not simple reactions to external facts. They are predictions about what situations mean for the body and what actions might be needed. Fear does not arise because a situation is objectively dangerous. It arises because the brain predicts danger and prepares the body accordingly. The intensity of fear reflects the urgency of action, not the accuracy of the prediction. This is why emotions can feel overwhelming even when we later decide they were unwarranted. In the moment, the brain commits to a particular interpretation because that commitment supports decisive action. Hesitation can be costly. Feeling certain, even when wrong, can be more adaptive than feeling uncertain and doing nothing. The sense of self works in the same way. Your experience of being a continuous, unified you feels profoundly real. It feels like a fact about the world. But this experience is also a construction shaped by the brain to coordinate perception, memory, and action. A stable sense of self is useful because it allows the brain to plan, to learn from past outcomes, and to maintain social relationships. The vividness of selfhood does not prove that the self is a fixed entity. It shows how important this construction is for functioning. Usefulness also explains why perception can change under different conditions. When you are tired, hungry, stressed, or excited, the world can look and feel different. Colors can seem duller or brighter. Time can seem to slow down or speed up. These changes are not random. They reflect shifts in what the brain considers important. When energy is low, the brain reallocates resources. When danger is anticipated, perception becomes more focused and narrow. The goal is always to support the body's needs. Crucially, this does not mean that perception is arbitrary or disconnected from the world. A useful model must still be constrained by reality. If your perceptions consistently fail to correspond to what is actually happening, they would not support survival. The brain's constructions are shaped and corrected by sensory input, but they are not driven by a commitment to truth for its own sake. They are driven by the need to keep the organism alive and functioning. This perspective can feel unsettling at first. If what we experience is not guaranteed to be accurate, it can seem as if reality itself is slipping away. But the opposite is true. Recognizing that experience is shaped by usefulness allows us to understand why perception is so powerful and so convincing. The brain makes its constructions feel real because hesitation and doubt would interfere with action. Confidence is part of the design. It also helps explain why disagreements about perception, belief, and interpretation are so common. Different brains, shaped by different histories and needs, can construct different, yet equally functional versions of the world. Each version feels real to the person experiencing it, not because it is objectively correct, but because it works well enough within that person's context. Once we see that the feeling of reality is a signal of usefulness rather than truth, we gain a new kind of freedom. We can take our experiences seriously without taking them as absolute. We can recognize that what feels real is the brain's best attempt to help us navigate a complex world, an attempt that is deeply intelligent, deeply embodied, and always open to revision as circumstances change. When people encounter an illusion, The usual reaction is to treat it as a trick or a mistake, something that briefly disrupts normal perception. We assume that illusions are rare glitches in an otherwise reliable system, exceptions that prove the rule that perception generally shows us the world as it is. But from a scientific perspective, illusions are far more important than that. They are not curiosities at the edges of perception, they are windows into its core mechanisms. Illusions reveal how perception really works precisely because they show us what happens when the brain's normal strategies are exposed. To understand why illusions are so informative, we need to reconsider what perception is for. If perception was simply about copying reality, then an illusion would indeed be a failure. But if perception is about making useful guesses under uncertainty, then illusions are the natural consequence of a system that relies on assumptions. The brain must make assumptions because sensory data is always incomplete and ambiguous. Illusions arise when those assumptions are applied in situations where they no longer fit. Consider a simple visual illusion where two identical shapes appear different in size depending on their surroundings. The light reaching your eyes from those shapes is the same, yet your experience differs. This is not because your eyes are malfunctioning, but because your brain is interpreting the signals using context. In the natural world, context usually helps. Objects that appear smaller often are farther away. Objects surrounded by certain cues are often larger or smaller in reality. The brain has learned these regularities through experience, and it applies them automatically. In the artificial setup of an illusion, those helpful rules lead to a misleading result. What this shows is that perception depends heavily on prior expectations. The brain does not wait passively for data and then decide what to see. It actively interprets incoming signals based on what it expects to find. Illusions make these expectations visible. They expose the invisible assumptions that normally operate so smoothly that we never notice them. This is why illusions persist even when we know they are illusions. You can measure the lines, remind yourself that they are equal, and still see them as different. Knowledge does not override perception because perception is not driven by conscious belief. It is driven by deeply embedded predictive processes that operate below awareness. Illusions reveal that seeing is not a decision, it is an automatic inference. Illusions also show that perception is economical rather than exhaustive. The brain does not reconstruct every detail of the world. It fills in gaps, smooths over inconsistencies, and prioritizes patterns. For example, in certain illusions, the brain completes shapes that are not actually there. You see contours, edges, or motion where none exist. This filling in process is not a bug, it is a strategy. In everyday life, objects are often partially hidden, poorly lit, or briefly glimpsed. Completing the picture allows for faster and more reliable action. From this perspective, illusions are not special cases where perception breaks down. They are ordinary perception operating under unusual conditions. They reveal the rules of the system by showing what happens when those rules are pushed beyond their usual range. Illusions also highlight how deeply perception is tied to the body. Some illusions involve not just sight but the sense of touch, balance, or body ownership. In these cases, people can feel as if a fake hand is their own, or as if their body is located somewhere other than where it actually is. These experiences can be startling, even unsettling, because they challenge our sense of self. Yet they follow the same principles as visual illusions. The brain integrates signals from different sources and constructs the most plausible interpretation. When visual information strongly suggests one thing and bodily signals suggest another, the brain may prioritize one over the other. What these illusions reveal is that the sense of having a body is not given directly. It is inferred. The brain continuously predicts what belongs to the self and what does not. When those predictions are manipulated, the experience of self can change. This shows that even something as fundamental as bodily ownership is an active construction, not a fixed fact. Illusions also demonstrate that perception is shaped by experience and learning. People from different cultures, environments, or developmental histories can experience the same illusion differently or sometimes not at all. This variability tells us that the brain's assumptions are not hardwired in detail. They are learned. Perception reflects the statistical structure of the environments we grow up in. Illusions exploit these learned structures, revealing how perception adapts to the world it expects. Importantly, illusions do not imply that perception is useless or unreliable. On the contrary, the very fact that illusions are predictable and systematic shows that perception follows consistent rules. Those rules are generally well suited to natural environments. It is only in carefully designed situations that they produce surprising results. Illusions reveal not chaos but order. By studying illusions, scientists can infer the hidden processes that generate experience. They can test which cues the brain relies on, how different sources of information are weighted, and how predictions are updated. Illusions turn subjective experience into a scientific tool. They allow researchers to reverse engineer perception by observing when and how it deviates from physical measurement. Perhaps most importantly, illusions remind us that the feeling of seeing reality directly is itself part of the illusion. When perception works well, we are unaware of its construction. The world simply appears. Illusions pull back the curtain. They show that what feels immediate and obvious is actually the result of complex, unconscious inference. They teach us that certainty in perception does not come from access to truth, but from the brain's confidence in its own predictions. Once you understand this, illusions are no longer just tricks. They become demonstrations of how perception always works, even in everyday life. They reveal that what we see, hear, and feel is not a mirror of the world, but a carefully controlled construction shaped by expectation, context, and the needs of the body, a construction that usually serves us extremely well, even though it is never a perfect reflection of reality. Understanding that perception is an active construction rather than a direct window onto reality does more than change how we think about the brain. It reshapes how we understand ourselves and how we relate to the world and to each other. This shift is not just a scientific insight, but a deeply human one, because it touches identity, belief, emotion, responsibility, and meaning. Once you accept that experience is something the brain builds, not something it simply receives, many familiar assumptions quietly begin to loosen. One immediate change is how we think about certainty. If what we see and feel is the brain's best guess, rather than a guaranteed truth, then absolute certainty becomes harder to defend. This does not mean we must doubt everything or become paralyzed by skepticism. Instead, it invites a kind of intellectual humility. Our experiences matter deeply, but they are not infallible. Recognizing this makes room for curiosity rather than defensiveness, especially when encountering perspectives that differ from our own. This has powerful implications for how we understand disagreement. When two people interpret the same situation differently, it is tempting to assume that one of them must be wrong or irrational. But if perception itself is shaped by prior experience, expectations, and bodily states, then different interpretations can arise naturally. Each person's brain is constructing a world that makes sense given their history and needs. This does not mean all views are equally valid in every context, but it does mean that disagreement is not always a failure of reason. Often, it is a reflection of different internal models at work. This insight can soften social conflict. It encourages listening rather than immediate judgment. If someone sees the world differently, the question shifts from why are they wrong to what experiences and predictions might be shaping their view. That shift alone can transform conversations, relationships, and even how societies navigate division. The idea that perception is constructed also changes how we relate to our emotions. Emotions often feel like direct responses to the world, as if situations force feelings upon us. But emotions are also predictions, shaped by how the brain interprets what is happening and what it expects will happen next. Seeing emotions this way can be empowering. It suggests that emotions are meaningful signals, not enemies to be suppressed, but it also reminds us that they are not absolute verdicts on reality. This perspective can help reduce self-blame and confusion when emotions feel overwhelming or contradictory. Instead of asking, "Why am I like this?" we can ask, "What is my brain trying to do right now?" Emotions become understandable responses shaped by learning and context, not personal flaws. This understanding can create space for compassion, and growth. The sense of self is also transformed by this view. The feeling of being a single, stable me feels fundamental, as if it must be a fixed thing. But if perception is a construction, then the self is too. The self is not a hidden object inside the brain. It is an ongoing process the brain generates to organize experience, memory, and action. This does not make the self unreal or meaningless. It makes it dynamic. Seeing the self as a process rather than a thing can be liberating. It means that change is not a betrayal of who you are, but an expression of how the system adapts. It means that feeling different over time is not a loss of identity, but evidence of a living, learning brain. This can be especially important during adolescence, when changes in emotion, identity, and perspective can feel unsettling. Understanding the self as something the brain actively constructs can make those changes feel less like chaos and more like development. This framework also reshapes how we think about responsibility and agency. If the brain is constantly predicting and constructing experience, then behavior is not simply the result of conscious choice layered on top of perception. It is deeply connected to how the world is experienced in the first place. This does not remove responsibility, but it adds nuance. It encourages us to think about how environments, habits, and experiences shape the predictions that guide behavior. In education, this insight highlights the importance of context and expectation. Learning is not just about delivering information to passive minds. It is about reshaping the predictive model students use to understand the world. Curiosity, engagement, and relevance matter because they influence how the brain constructs meaning. Teaching becomes less about transmission and more about transformation. In mental health, the implications are equally profound. Many forms of distress involve rigid or unhelpful predictions about the world, the body, or the self. Seeing experience as constructed suggests that change is possible, not by denying experience, but by gently updating the models that generate it. This does not mean thoughts and feelings can be switched off at will. It means they can, over time, be reshaped through new experiences, relationships, and perspectives. Even our relationship with reality itself changes. Reality does not disappear or become irrelevant. Instead, it becomes something we interact with through models rather than mirrors. This makes science especially valuable because science provides tools for testing and refining our models beyond personal experience. At the same time, it reminds us that lived experience has its own kind of truth, grounded in usefulness rather than objectivity. Perhaps the most inspiring consequence of this view is that it reveals how creative the brain truly is. Every moment of experience is an act of imagination constrained by the world and the body. Seeing, hearing, feeling, and being are not passive states but achievements. The brain is constantly working to turn uncertainty into meaning, chaos into coherence. Once you see perception this way, the world does not become cold or mechanical. It becomes astonishing. Ordinary experience reveals itself as something fragile, adaptive, and deeply alive. The simple act of looking around becomes evidence of an intricate process unfolding beneath awareness, a process that makes a world appear and places you within it, not as a detached observer, but as an active participant in the ongoing creation of experience.